So before starting the exercise, we should know some properties which are related to rational and irrational numbers. So x, if x and y are two real numbers, are two real numbers, and x is where x is rational number, x is rational means one is rational number and y is an irrational number. Y is an irrational number. Then means we are going to see that when we add irrational and rational number, when we subtract irrational and rational numbers, for example 3, adding 3 plus root 2, root 2 is irrational, subtracting and multiplying rational and irrational, so what will be the result? Their sum, their multiplication, their addition means what will be the result? Means their answer will be whether irrational or rational. So when you add 3 plus 2, so this will be irrational number. In all cases, you get irrational number actually. If you add irrational and rational number, x plus y is an irrational number, is also an irrational number. For example, I have given this, you can write here. For example, you take one irrational number and one rational number. X is a rational number, so you can take 2. 2 is a rational number and under root 2 is an irrational number. 2 plus root 2, if you will add, it will be an irrational number. It is an irrational number. It will become irrational number. On adding rational and irrational, it will become irrational number. Okay. Similarly, there we subtract x minus y is 2 minus root 2 is also an irrational number. Is an irrational number. For example, same, you can write 3 minus root 3. 3 minus root 3 is the difference of rational and irrational, but its result will be is an irrational number. If we multiply an irrational number with irrational number, means x into y, 3 into root 2, so that will be also an irrational number, is also an irrational, is also an irrational number. For example, you can multiply 2 into root 5, so this will become 2 root 5. Sorry, 2 root 5. 2 root 5 is also an irrational number, is irrational. Similarly, if we divide x by y, then it is also an irrational number. It is also an irrational number. Example, root 2 divided by, or we can take first, it is whether we write, sorry, whether we write root 2 first or irrational number first, rational or irrational, but their result will be irrational number. So if we write first, we have taken x as rational number, so that's why the 2 divided by root 3 is an irrational number, is an irrational number. So we have seen that multiplication, addition, subtraction of rational with irrational is always irrational. Okay, this property you should remember because we will study rationalization. Okay, we will study rationalization. Before that, some more properties are there for positive numbers. Let A and B be positive real numbers. This property belongs to only positive real numbers, means greater than 0. Positive real numbers which are greater than 0. Then you may have seen in class 8 under root A into B. If two numbers are in the root, so we can write their roots separately, or we can write opposite of this. If it is given separate roots, we can write in the same root. Opposite of this, or same thing. We have given root 2 into root A into root B. We can write root A into B. We can multiply them and write the root. For example, you write suppose 2 into 3, root 2 into 3, root 6. You can write root 2 into root 3. Or if you have given root 2, this will be used more, root 2 into root 3. It is separately written. So if we need there, we can write 2 into 3. That will be equal to root 6 because they have same power. Then same thing, it is in multiplication. If it is in division also, if only in one root you have given the two positive numbers, but remember these all are positive numbers, 2, 3 greater than 0. It can be in decimals also. It's A by B because the real numbers but positive. So this can be written root A divided by root B. So we can split the root in division also, or vice versa. We can have if a root A upon root B is given, we can write in the same root, means we can divide first and then take root, or first take root separately and then divide, same thing. Examples, if you have given suppose root 2 on root 3, any number, you can write in same root 2 by 3, or opposite of it also. Similarly, we have some more formulas which we can use directly, but that are based on the previous formulas that you have studied already, that A plus B net class, A plus B into A minus B is equal to A square minus B square. Okay, this formula, you must remember it. Anytime it can be used. Here they have directly used this formula, and we can have under root A plus under root B. When you multiply with under root A minus under root B, actually from this formula it will become square. So we will have actually under root A A is under root A here in this formula is under root A square minus under root B square. But square root of a root will become cancelled. So it will become A minus B. For this also remember that root of any number. You have a root of any number and you take a square, this will become x only. Why? Because root means x raised to power 1 by 2, not 2. Okay, to the power 2. And law of indices we will study again, but we studied in previous classes. 1 by 2, that this 2 and 2 cancels, so x raised to power 1 x. That's why root of a square is equal to always the number itself. Similarly, the fourth property also same. Here they have given a plus. So whatever it is given, suppose these two numbers are same, it should be this number should be same to this number, and if this number is same to this number, and they have plus and minus, then we can use this formula. So here also we can see that a plus root b and a minus root b. So this will be equal to a square minus root b square. A square minus root b square, and the result will be equal to a square minus b only, because root and square will cancel. And if you have to multiply, suppose here we have taken the root on both the numbers and add subtract multiplication of their sum and difference. Here also, but one number is not root number, means one, these both are irrational number, here one is rational number. Similarly, if you have both are rational numbers, means both have roots, root a plus root b, and they are different, so you will multiply, simple multiply. Under root a plus under root b multiply with under root c plus under root d. You can write here examples. Some examples you can take, suppose root 2 plus root 3 into root 2 minus root 3 will be equal to 2 minus 3. And here you can take the example 2 plus root 3 into 2 minus root 3 will be equal to 2 square, means 4. 2 square means you can write 2 square minus 3 or 4 minus 3. So similarly here you will multiply under root a, first multiply under root a plus under root c. So you can write under root ac from this formula, under root ac. Okay. Then you multiply under root a with under root d. So simple multiplication, it will be under root ad. Okay. Then you have to multiply with under root b with under root c. So this will become plus under root bc. Then you have to multiply under root b with under root t under root d. So it will become under root bd. Okay. So simple multiplication. And when you have whole square, so you have whole square means root a plus root b, root a plus root b whole square. So you know that this is simple formula, a plus b whole square. You remember this right here, a plus b whole square and a minus b whole square. So a plus b whole square is equal to a square plus 2ab plus b square. This formula will be used here. So a square means root a whole square plus 2 into a. A is what? Root a into root b plus root b whole square. Root b whole square. So your result will be a plus 2 root ab. The same root you can write, and plus root b square is b. Similarly, if you have minus here, so a minus b, a minus b whole square is equal to a minus b whole square is equal to a square minus 2ab plus b square. So remember, these are same formulas here. If it is plus, you will write here plus 2ab. If it is minus, you will write minus. So if the sixth one property is root a minus root b whole square, then the sign will be changed only. Root a whole square, we can write root a whole square and root 1 minute root a whole square, Imran, minus 2 root a into root b plus root b whole square. The root a whole square is a minus 2 root ab plus root b square is b. Actually, this needs, if you are not understanding, Imran, because you need to have the basic from class 8, these formulas and everything. Root, square root we studied in class 8 actually. Okay, so that's why. So whenever we are simplifying, we are using these things for simplification. Okay, and one more thing is there, that is called rationalization. So before coming to that one, we can start, we can have some questions from the exercise. Then I will tell you what is rationalization. So page number, take out your page number 24. Your textbook, page number 24. Page number 24. See, this is 21, 22, 23, and 24. The exercise 1.5, 21. First question. Okay, okay, okay. Okay, man. You're understanding. I thought you said. Okay, okay. So 1.5 exercise. Here the question is, classify the following as rational or irrational number. But you should solve them and then check. Do not write directly it is sum and product. We have seen the properties, but you should check 2 minus root 5. It is further not solvable, but you know that difference of irrational and rational is irrational. 2 minus root 5 is irrational. Correct? And second, second question, you have to solve first, simplify it and then check. This question, if you will not simplify, you can write the wrong answer. Here you have to simplify this one, okay? And then you can write the, we studied, if you are not attending all classes, uh, who wrote this message? 1 minute, let me see. Arya, we haven't learned how to represent irrational number on number line. You think that we didn't do? We have done it. This one, root 2. What is the value? What is root 2? What is root 3? What is root 5? They all are irrational numbers. Okay, and they are irrational number, non-terminated, non-recurring decimals. But I told you how to represent spiral diagram, and if under root 5, under root 5 can be represented directly. No need of a spiral diagram. Why? Because 5 square is equal to 2 square plus 1 square. So we have done this one. You are sleeping. This is 1. Here we have taken 1. Here we have taken 2. And this was the number line. And like this we did. If you remember, this will be root 5. Okay. If we ask root 3, then you have to draw the line. Take here 0, 1. Here also 1, 1, 1. And then join. This will be your root 2. And when you here you take perpendicular. Here you have to take perpendicular. I told you some of you are not taking here perpendicular, and this length should be 1. Then this will be root 3, and you have to draw the arc. This point will be root 3. How you are saying we have not done irrational number? This is what, where you have the numbers means which are not perfect square but whole numbers. But if you have given 2.375, we have done yesterday. If you have 2.2 recurring up to 3 places of decimals, 2.222, that is also represented on the number line. Yesterday we have seen the successive magnification. This we will have to do by successive magnification. It looks like that either you didn't study or you were not attentive in the class. So we have done irrational numbers, two types. How many types of irrational number? Non-terminating, non-recurring decimals, irrational. So this is irrational. This is also non-terminating. This is non-terminating recurring. Non-terminating, non-recurring. This is irrational. This is non-terminating recurring rational. This is rational. So we have done all type of numbers, rational, either rational or irrational. This is terminating decimal. This is non-terminating repeating decimal. So both are rational numbers, and this is irrational number. One more thing is left. That diagram I will tell you at last actually. That is, if you have given suppose root 2.3, root 9.5 like that. If decimal is given in the root, that diagram is quite different from all these diagrams. Okay, so that is only left part. So that I will do it after finishing 1.5 and 1.6. At last, one diagram is left. I told you I will teach you that diagram also. I skipped that diagram now because yesterday only I taught you the diagram. So if I will teach you daily diagram, you will get bored. That semicircle diagram I told you, that is for decimal. We will do that one, and that will be done at last after finishing this exercise 1 point, or in 1.5 there is only one question in your textbook like that, 9.3, but we will do more question after that. We have extra questions also. So don't worry, I will not leave anything. I am teaching extra, not only exactly the given in your textbook, but extra things will be taught later on after finishing this. So this will be cancelled. We get 3, and 3 is rational number. So therefore, the given number is rational, not irrational. So you have to solve. If it is not in the simplified form, you have to solve and then check. Do not check directly. Okay. Okay, got it, Tarya? Okay. Okay. So third question is, now again third question, 2 root 7. And it looks like 2 root 7, 7 root 7. No, you cannot write directly because root 7 will cancel. This will become 2 by 7. P by Q is rational number. So this is also a rational number. Okay, are you getting? Yes, Imran, we will do maths lab in we have the virtual math lab also. Okay, we have the activities. I will show you online activities. Math lab you have to do. You have to make one more notebook for math lab activities that will be started inshallah after finishing the portion for test 1. Inshallah, we will do some activities, Imran. Yes, we used to go to math lab during math period activities, but this time also we have. So that 15 marks, you know that your marking scheme is divided into 80 and 20 marks. This 20 marks is internal, in which it is included that math lab activities are also included. Okay. Fourth, 1 by root 2, 1 by root 2. So numerator is rational and it is irrational. So rational upon irrational, we have seen that is an irrational number. So it is irrational. Obviously, it is irrational. So that is the only how to recognize rational and irrational. Yes, remember that pi. What is the value of pi? Pi, we used to have the value of pi. You don't know, just remember this one. Pi is a constant symbol which is used in area of triangle and mensuration and in all the formulas, most of the formulas of mensuration. This pi is having 22 by 7. Value of pi is 22 by 7. Yes. Yes, Ubedullah, correct. 3 point, not 24. Ubedullah, you have written 24. It is 22 by 7. When you divide 22 by 7, this will become 3.14. Okay. So 3.14. So from this value, it looks like what? Rational or irrational? Looks like rational, but pi is not rational. It is irrational. It is not terminating, non-terminating, non-recurring decimal. So just remember that pi is irrational. Pi is irrational. Okay. So when you multiply pi with any number, 2 pi, 3 pi, 4 pi, all are irrational numbers. So that's why 2 pi is an irrational number. Is an irrational. Yes. How is pi irrational? Very good question. Is an irrational. Pi actually, what is pi? Okay, we will see. What is pi actually? When you see any circle, you have, suppose you have this circle, okay, and this is your radius and this is your circumference. So what is the formula of circumference? Circumference is equal to 2 pi r, or you can write pi d. Okay, so pi is equal to circumference upon diameter. Circumference upon diameter. So if you will find any circle, you can take any circle, small one, big one, any circle, take more circles and find its radius and circumference first. And if you will find the ratio of circumference divided by diameter, so it will be always a non-terminating, non-terminating, non-recurring, non-terminating, non-recurring decimal. Means when you will divide this, this will not terminate and it will not end. So many mathematicians tried to find the value of pi up to, I think, many number means up to, I think, lakhs or thousands or millions decimal places, but it was not terminated. So that's why it was done by mathematicians. They tried to get the exact value, but it was going on without repeating. So that's why it is Pi is an irrational number. So this is the fact actually. Whenever you will find any circle, if you will find circumference divided by diameter, you will get this value 3.142 like this. It will never end. Okay, so that's why this is the special case. Hope you understood. Ubaidullah. Yes, it is non-terminating, Ubaidullah. Yes, pi is irrational number because it is non-terminating and non-recurring decimal. I told you non comes two times it becomes irrational. So that's it for today. Okay, we have only one period today, so I'm going to wind up now.